Hello students, so let's start with the revision of current electricity. Let's start with drift velocity. The drift word means sudden change. Like if something is moving in a particular direction, let's say in this direction with some velocity v, and we applied a force in this direction, that is F, then what will happen? This particle will move in this direction. So this sudden change will be the drift. And now drift velocity means, like for example, an electron inside, like for example free electron, and free electron is moving inside a conductor with certain speed. One question is there, why do the electrons move at room temperature? From where they are getting energy? This is the question from you. Now, for example, like electron, this is negatively charged particle and is moving in a particular direction v, and I have applied an electric field which is in this direction. Assume that this is the electric field. So electric field, what is the direction of electric field? The electric field direction will be plus and minus. So you can say from positive to negative. Now this electron, tell me, this electron will experience the force in which direction? So if I draw, because electron is a negative charge particle, so this will experience a force towards positive end of the conductor. Now one more question for you, just tell me what is the force experienced by the particle electron? That is minus E and E. This is from the formula of F equal to QE. Now, if electron having a force in this direction because of the electric field, so tell me in which direction the particle will move. The simple thing is, particle will move in this particular direction. And after that, you just make out one thing. Earlier the particle was here. Now, because of this electric field, the particle will reach here, and it will cover a displacement in the direction opposite to the electric field. So this displacement, let's say S, this is the displacement, and so displacement upon time will be equal to velocity. So now this is for one electron. Now you know how many electrons are there in a conductor. So they are 10 raised to power 29 electrons per meter cube in a conductor. So this is huge in number. So we'll not talk about one electron, we'll talk about the average of all the electrons, average of all the velocities. Okay, so now so we'll write down the first thing is clear, that velocity will be average. Velocity will be average, it will be average velocity. Okay, and this is due to the application of electric field, okay, in a particular direction. So which direction it will be? Can I say the electrons are moving towards the positive end of the conductor? Yes. So this is the velocity with which electrons are drifting towards the positive end of the conductor, positive end of the conductor. And the third thing is when an electric field is applied across the conductor, okay, across the conductor. So this is very important thing. Now we are going to derive the formula for drift velocity, and before doing that, we'll understand the method what we are going to do. So to do this, we'll take a conductor, and that conductor is placed at room temperature. This is fine. So one thing is conductor, and conductor placed at room temperature. And the second thing is, first we will find out average velocity, because drift velocity is the average velocity. So we'll find out the average velocity without applying electric field, across the conductor. This is the one thing we'll do. And the second thing will again find out the velocity with electric field. If you can remember these two lines, you can easily find out the derivation. You can easily remember the derivation. These are the two things. Okay, like how we will find out, that is a different part, but what we are going to do, that is very, very important. So I will apply these two things very simply, these two steps, and we'll get drift velocity easily, and you can remember that very easily. So first thing, let's find out. First thing, you have a conductor and at room temperature, no electric field is applied. Already we discussed there will be random velocities, and because of that random motion of the electrons, there will be average velocity, and that average velocity will be 0. Okay, so I'm just writing V average here, and this V average will be U1 plus U2 plus U3 up to UN. Is that okay? Divided by N, and that value will be 0. Now this is first thing, and when we are finding this is without electric field, because this is the initial velocity U1 U2 and they are randomly oriented, and because of this random orientation, the sum of all the velocities of all the electrons will be 0, and this is how average is 0. Okay, and the next point is when we apply electric field. Okay, as we already understood, when we apply electric field, there will be an acceleration. Before that, like, there will be force on the electrons, and if there is a force on the electron, there will be an acceleration. Okay, so electric field aate hi, there will be a force. Because of that force, there will be an acceleration, and that acceleration value I can find out. Acceleration will be F upon m. Because of this acceleration, there will be change in velocity. So earlier velocity was constant, now velocity will be changing with time because it is accelerated motion under electric field. So just find out all the velocities, new velocities. So which equation we will use? V equal to U plus AT. In different time we will find out. So let's say V1 is the velocity, final velocity of an electron due to the electric field. U1 is the initial velocity. A is the acceleration, because all the electrons are same. So mass will be same, force will be same, so acceleration will be same. So only thing is different time. And what is this time? We are taking this time as the time between two successive collisions. Okay, time between two successive collisions. So this is how we can write equation number 1, and this equation is for the velocity of the first electron, and similarly velocity of the second electron you can write then. So U2 plus A into T2. Now time T2 is the time between two successive collisions, and similarly you can go for and switch to n particle. So V1, V2, V3 and up to n you can write, and similarly I can write Un plus A into and Tn. Okay, so this is the velocity of nth electron. So let's find out the average of this as per the method. As I told you the method, like one method is average without electric field, and this time we are applying electric field, so we'll write down this. So this is then again average. So average will be V1 plus V2 plus up to Vn you can write. So this is the average of all the velocities which is under the effect of electric field. Average velocity is V1. What is the value of V1? If I put, let me write first this V1, V2, and this is V3, and this is Vn divided by n. And now what is V1? V1 is U1 as you write AT1, and this is for acceleration, and plus U2 plus AT2 plus u3 plus a t3 up to the last thing un plus a tn. Okay, so now divided by n. So this is the formula right now. And let's say keep all the velocities, initial velocity. What is u1, u2? It's a velocity without electric field. So you can say initial velocity. So keep all the velocities together. So I took like this plus C. This A is common in all the terms. So I just write down A into, I'll write T1, T2, T3 up to Tn. So this is how you can write, and divided by n. So I am dividing it separately. So we are distributing it. Is that okay? Now, what is the value of this term? The value of this term will be 0. Because of this velocity will be 0. So only this term is very, very important for us. Okay, this term is very, very important. This term is very important. So this will give you the velocity. So average velocity will be now A T1, A is the vector quantity, T2, T3 up to Tn divided by n. Okay, now here I want to talk about this T1, T2, T3. Actually, when electrons are going and they are colliding, they are having collision number 1, collision number 2, collision number 3, collision number 4. Okay, so now when they are moving like this, collision 1, collision 2, collision 3, all time will be T1, T2 and T3. This is how we are taking time. And this time is the time between two successive collisions, and this time is called relaxation time. So take an example where you have done something wrong and your mother is giving you slaps, number of slaps, continuously slaps. So in between two slaps you have a little time to have some relaxation. So I'm just taking an example for fun. Okay, so this is relaxation time. So दो थप्पड़ के बीच में जो time मिलेगा वो time होगा relaxation time. So this relaxation time, if you say T1 plus T2 plus 3 up to Tn, so this term actually giving the average of the relaxation time. Okay, because these T1, T2 and Tn, they are average time, average relaxation time. So this complete will be an average of relaxation time is tau, and this tau is equal to T1 plus T2 plus T3 up to Tn divided by n. So this is how you can find out average relaxation time as well. So this is average velocity, and as we know, this average velocity will be the drift velocity. We can write it as Vd. So simply the formula comes to be, the final formula we have for drift velocity will be acceleration of the electron and average of relaxation time. So this is tau, average of relaxation time. This term, this equation is very important. The formula is very important. Now just elaborate this formula. As you know, we have an electric field. This electric field apply a force on the charged particle and the electron, that is electron, and how much force is it is applying, that is QE. Because of this QE, there will be an acceleration. So acceleration, how can you find out? That force upon mass, Newton's second law, F equal to ma. So A will be equal to F by m. F is QE by m. You know we are talking about electrons, so we'll write down minus E, capital E, divided by m. So this is acceleration of the electron, and tau is the relaxation time. So final thing is, so drift velocity relation will be minus E, capital E over m into tau. So you know now each and every term. Is that okay? Hopefully you understood this This is very important point. Now my question is, what is the importance of this negative sign? So negative sign suggests us that if we apply an electric field in this direction, electron will drift towards, in which direction? Opposite to the electric field. Drift velocity will be opposite to electric field. Okay, you can remember this derivation if you know the method. So just go for method and then